What if the Earth itself were a kind of vast and patient library, but one that forgets almost as much as it remembers? When we look at the layers of stone beneath our feet, we are really looking into pages that were written slowly over millions of years. Each layer is like a record of what once was: a seafloor hardened into limestone, a riverbed pressed into sandstone, a layer of volcanic ash frozen in time. Yet this book is not complete, and not every page has survived. The Earth is a restless keeper. It folds, erases, and rewrites its own chapters. Whole sections crumble away under wind and water, so what we hold in our hands is not a complete story, but fragments. Now we can gently pause and picture how these fragments form. Imagine mud at the bottom of a shallow lake, settling grain by grain. Over centuries, it thickens, hardens, and becomes shale. Tiny shells might be trapped inside, or pollen carried by the breeze. These small inclusions become signals, like letters left behind, allowing us to read something of the environment that once existed. In this way, the rocks become witnesses, though they never speak directly. They offer hints, not narratives. Still, the hints are enough for us to see patterns. In some layers, we find sudden changes, an abrupt absence of certain fossils, a thin band rich in rare elements like iridium, or a shift in the balance of carbon and oxygen. These are markers of events: an asteroid strike, a mass extinction, or a period of unusual climate. The record is indirect, but it is often the only kind we have. What makes this even more delicate is how incomplete the layers are. We do not have a continuous film of Earth's history, but scattered frames. Entire millions of years might be missing, erased by erosion, never deposited at all, or buried so deep we cannot yet reach them. Absence in these layers does not mean absence in reality. It only means we have not yet found, or perhaps never will find, the traces. Now we can linger briefly on how this affects our thought. If another civilization had arisen long before ours, the chance that its material remains would endure in stone is vanishingly small. Metal tools corrode quickly, concrete crumbles, even monuments would wear down in the slow patience of rain and wind. Only under rare conditions, rapid burial, protection from oxygen, isolation from water, could a trace survive. Even then, over hundreds of thousands of years, pressure and heat might transform it beyond recognition. And so we are left with uncertainty. We cannot point to stone layers and say with confidence, "Nothing happened here." We can only say, "Nothing has yet been seen." To understand this, let us try a simple thought experiment. Imagine our own world, with its cities and bridges and archives, suddenly abandoned. Suppose time passes. After 10,000 years, forests spread over concrete, rivers eat away at the steel, frost shatters glass. After 100,000 years, only faint outlines remain, softened into hills. After 1,000,000 years, most is gone, and the few remnants are sealed under new sediments. By the time 10 million years pass, the record is a handful of altered minerals, perhaps a chemical signature locked into a layer of stone. If future beings read those layers, what would they know of us? Perhaps only that something unusual once disturbed the Earth's chemistry. In this way, we begin to see how fragile memory is when written in stone. Yet stone still carries more than silence. It holds subtle languages we can learn to hear. The balance of isotopes, tiny fossils of microorganisms, the dust of ancient deserts. These are not words, but signals, signals that must be interpreted carefully, with humility. We never hear the full sentence, only scattered syllables. And that is enough to remind us of the vastness of time and how much of it has already slipped away. The stone witnesses are patient, but they are not perfect. They give us fragments, and in those fragments we may sense both presence and absence, What they cannot give us are final
answers. We are left, instead, with the soft possibility that much has happened beyond our reach, and perhaps that quiet uncertainty is the truest memory the earth can offer. What if time itself were so vast that our entire story, from the first stone tools to the satellites circling above us, is no more than a faint breath in its rhythm? When we think in human years, a century feels long. 1,000 years feels immense. But the earth does not count time in centuries. It measures in millions, in billions. To understand this, we may imagine the planet as an ancient clock, ticking so slowly that we can hardly notice its hands moving. On such a clock, everything we know, writing, farming, cities, has unfolded in less than a moment before midnight. Now let us gently pause on what this means. If the earth has lived for more than 4 billion years, and we have traced human presence for only a few 100,000, then almost the entire expanse of time lies beyond our record. Civilizations, if they had appeared earlier, could have risen, flourished, and fallen without leaving signs that survive into our present. This is not a claim, only a possibility. The silence of evidence is not proof of absence. It is simply the way deep time folds itself around what has passed. To picture it more clearly, let us try an everyday comparison. Imagine a long roll of fabric stretched out across a hall. Each meter stands for millions of years. At the far end is the origin of Earth. Along its length are faint marks, volcanoes, oceans forming, continents drifting. Near the very edge, at the last thread, is everything we call human history. The rest of the cloth is blank to our eyes, not because nothing happened, but because most traces are gone, erased by the slow work of time. Time erases in many ways. Mountains rise only to wear down. Rivers cut valleys, then shift their course, burying what lay before. Ice sheets grind the land. Oceans drown the coasts. Deserts swallow cities. The processes are gentle in their pace, but absolute in their effect. What looks permanent to us is only temporary in their scale. A monument of stone may stand for thousands of years, but in 100 million it is gone, as surely as a footprint on sand. Now we can linger on how science approaches this vastness. Geologists read the record of time in layers of rock, each layer like a page in a long and broken chronicle. Fossils, minerals, isotopes, these are the markers, the letters. Yet not every layer is preserved. Entire chapters may be missing, torn away by erosion, or never written at all. This is why knowledge of deep time is cautious. We can say with care what we see, but we must admit the gaps. We do not know what has been lost. Let us gently imagine a thought experiment. Suppose an advanced society had lived 50 million years ago. What would remain of it today? Step 1. After a few thousand years of abandonment, most of its visible works would have decayed, covered by soil or water. Step 2. After 1,000,000 years, the shifting of continents and the cycling of climate would have buried or destroyed nearly everything. Step 3. After 50 million years, only the most subtle chemical changes, traces of metals, patterns of carbon, might linger in stone, faint and ambiguous. Would we recognize them for what they were, or would they blend into the natural background? This uncertainty is why we must stay humble when speaking of time. The markers we search for are small, scattered, often unclear. The absence of cities, of artifacts, of direct evidence does not mean nothing happened. It only means that if something did happen, the earth has hidden it well. And so the language of deep time is a quiet one. It speaks not in stories, but in probabilities and patterns. It asks us to listen gently, to accept that much is unknowable, and that our own place in time is brief.
What if almost everything we build, everything we shape with our hands, is destined to vanish, leaving barely a whisper in the layers of the earth? We often imagine human creations as lasting, yet the truth is that materials fade quickly compared to the slow patience of geological time. Metals corrode, wood decays, paper turns to dust, even stone softens under rain and wind. Within a few thousand years, much of what we know today would no longer stand. This fragility of traces is important because when we search for signs of other possible humanities before us, we must remember how easily evidence dissolves. Now let us pause gently on how this process unfolds. Take iron, for example. Strong and reliable in our daily use, yet when exposed to air and moisture, it rusts, breaking down into reddish powder. Over centuries, it loses form, blending back into soil. Wood, which builds our houses and carries our tools, disappears even faster. In damp ground, bacteria and fungi consume it until only dark stains remain. Stone lasts longer, but even stone wears away. Sandstone crumbles grain by grain. Limestone melts in weak acids carried by rain. Granite fractures under frost. What feels solid to us is fragile to time. Even glass, which seems resistant, slowly weathers, its surface turning cloudy, then breaking into shards, and finally, sand. When we think in human lifespans, these changes are almost invisible, but over geological stretches, they are absolute. This means that the absence of ancient buildings or tools does not prove they never existed. It only shows that their materials may not have survived. The earth has no obligation to keep our records. Now we can briefly notice the role of burial. Sometimes objects are covered quickly by soil, ash, or sediment, and this slows their decay. A wooden post sunk into clay might leave an impression centuries later. A pottery shard dropped into a riverbank may harden into the surrounding rock, but such preservation is rare and uneven. Most human traces are left exposed, and so they fade. Archaeology teaches us this lesson again and again. Entire cities, once filled with voices, have become little more than scattered fragments, broken pottery, outlines of walls, discolorations in the soil. From these small clues, entire lives are reconstructed. Yet we must be careful not to assume that what is absent never was. This is why scholars often repeat, absence of evidence
is not evidence of absence. The Earth is not a perfect archive. It is selective, sometimes generous, often forgetful. Let us try a simple thought experiment. Suppose a modern city is suddenly abandoned. Step 1. In 100 years, weeds grow through cracks, roofs collapse, streets become forests. Step 2. In 1,000 years, buildings fall completely, metals rust to nothing, and the land looks wild again. Step 3. In 10,000 years, only faint foundations remain, covered by soil. A visitor might find a shard of ceramic, a lump of concrete, a trace of glass. After 100,000 years, even these traces are likely gone, unless, by chance, they have been buried under protective layers. After 1,000,000 years, almost nothing would be visible, only a few subtle chemical changes locked into stone. From this, we learn humility. If our own presence could be erased so thoroughly, then earlier presences, if they existed, would be even harder to detect. The language of traces is fragile, written on soft pages that time erases. Yet sometimes faint signals survive. A concentration of certain metals in soil, a pattern of wear on rocks, a layer of ash rich in unusual chemistry. These are like distant echoes, requiring cautious interpretation. We may never know with certainty what they mean, but they remind us that the earth carries hidden whispers. And so we drift to a quiet conclusion. The fragility of traces does not close the question of earlier humanities. It only reminds us why silence in the record is expected. What we see is not the full story, but fragments, scattered and faint. In the gaps between them, there is room for possibility and room for wonder.
What if the stones beneath our feet were not silent, but careful witnesses, keeping records in their own quiet language? When we look at the surface of the earth, we see hills, rivers, and valleys, but beneath them lies a deeper archive. Rocks are not just solid matter, they are pages pressed together by time, layered slowly like sheets in a vast book. Each layer tells of an environment that once was, a shallow sea, a desert wind, a volcanic ashfall. And within these layers, we sometimes glimpse fragments of life long gone. Now let us pause softly and think about how these records are written. Sediment, which is simply particles of sand, silt, or clay, settles in water or air. Over time, it piles up, pressing older layers beneath newer ones. With patience and with the weight of centuries, these sediments harden into stone. Fossils of shells or plants, or even traces as small as pollen grains, may be trapped inside. Later, geologists read them as though reading the letters of a forgotten script. Yet the script is incomplete. Erosion, the slow removal of layers by wind and water, tears out whole chapters. Earthquakes fold and shatter the pages. Heat and pressure melt them into new forms. Much is lost, and what survives is often fragmentary. This is why the record in stone is a mosaic with missing tiles, not a full picture. And here we remind ourselves the absence of a tile does not mean there was nothing there, only that the piece has not been preserved. Now we can spend a moment with the ways we interpret these fragments. One of the most delicate tools is stratigraphy, which simply means reading layers in order from oldest below to youngest above. Within these sequences, we may find sudden changes, perhaps a thin black line of carbon suggesting fire, perhaps a layer enriched with rare elements hinting at an asteroid's impact, perhaps a shift in the types of fossils marking a change in climate or a mass extinction. Each is a clue, a quiet signal, but never a complete story. This is why geologists proceed with caution, piecing together multiple lines of evidence before drawing conclusions. Let us try a small thought experiment. Suppose a great city of stone once stood, then was buried by sand. Step 1. After thousands of years, the sand turns to sandstone, sealing outlines of walls. Step 2. Over millions of years, the sandstone itself is folded and fractured, scattering the patterns. Step 3. Later, erosion removes parts of the rock, leaving only a few scattered blocks. To us, those remnants might look natural, their origin hidden by time's transformations. Without context, even the most deliberate structure might appear as chance. This uncertainty shows the limits of what the stone record can offer. Now, let us linger briefly on the language of minerals. Certain shifts in chemistry can signal changes too subtle to see otherwise. For example, an unusual concentration of heavy metals might point to volcanic eruptions or to industrial activity if it happened in recent epochs. Shifts in carbon isotopes can reveal global changes in vegetation or climate. These signals are durable, locked into crystals and sediments. They are the closest thing we have to long-lasting whispers of events. Still, they are not always clear. Natural processes can mimic patterns that might also come from human action. So we tread carefully, knowing that interpretation can mislead. What we are left with is a balance: fragments, signals, partial scripts, none of them certain, but together forming glimpses of the Earth's deeper history. The stones are patient witnesses, but they do not testify loudly. They give hints, quiet and ambiguous, and much is left unsaid. And so we come to a gentle conclusion. The Book of Stone is not a book with full pages, but a scattered collection of half-remembered lines. It does not close the question of what may have passed. It only reminds us that time is vast, memory is fragile, and silence in the record does not mean silence in reality. In that quiet uncertainty, we find both humility and space for wonder.
What if the oceans, covering most of our planet, were not only waters of movement and depth, but also vast archives, keeping a memory of ages that the land has already forgotten? Beneath the waves, at the quiet floor, sediments drift down slowly, grain by grain, carried from rivers, from wind, from the remains of life that once floated near the surface. Over centuries and then over millions of years, these grains accumulate into gentle layers, each one a record of its time. Unlike the land, where erosion and weather sweep away traces, the seabed can preserve its pages more steadily. The pace is slow, but the patience is endless. Now, we pause for a moment to think about how this process works. When tiny organisms in the sea die, their shells, made of calcium or silica, sink to the bottom. they become part of the sediment. Dust from deserts travels across continents, falls into the ocean, and adds its fine particles. Even ash from distant volcanoes settles into the water, making its way downward. Layer after layer, these materials form a quiet history written in mud. Scientists call this process sedimentation, but we can think of it simply as the Earth's way of placing memory into storage. Within these sediments, we can find signals. Ratios of oxygen isotopes, for example, tell us about past climates, about warm and cold cycles that changed the face of the planet. The presence of certain chemicals might indicate great extinctions, times when life in the sea collapsed suddenly. Tiny fossils, visible only under a microscope, show which species thrived and which vanished. The language here is subtle but steady, giving us a longer perspective than almost any other archive on Earth. Yet there are limits. Much of the ocean floor is not old. Through a process called plate tectonics, the crust of the sea is constantly renewed. New rock forms at mid-ocean ridges, while old crust is pulled back into the Earth along trenches. This means that the oldest oceanic crust is only about 200 million years old, while the continents keep records billions of years long. Most of the seabed, therefore, holds only recent stories. Deeper ones have been erased. Still, within that time span, the memory is rich. Now, let us imagine a thought experiment. Suppose an advanced society lived near the coast many millions of years ago. Step 1. As the sea rose, parts of its settlements sank beneath the water, covered by sand. Step 2. Over thousands of years, mud and shells buried the remains, pressing them deeper. Step 3. Over millions of years, the ocean floor shifted and the layers either descended into trenches or remained sealed beneath thick sediments. If we were to search today, we might find chemical signatures, unusual deposits, or faint anomalies in the fossils. But the chances of recognizable objects surviving are small. They would be ground down, altered, and blended into the background of natural change. This does not mean absence. It means difficulty of detection. And so we tread carefully, knowing that the sea may hold whispers we cannot yet hear. The ocean is both generous and secretive. It stores evidence with patience, but also hides it beneath vast depths, making access hard. Drilling into cores of sediment gives us glimpses, narrow but telling. Within these cores, we see shifts in color, changes in composition, sudden lines of ash or darkness. Each line is a quiet bookmark, marking fire or flood or change. Together, they form a timeline that stretches beyond the reach of human memory. As we reflect, we see that the ocean's memory is not absolute. It is patchy, fragile, open to interpretation, but it is one of the longest and most reliable voices we have for the Earth's past. It shows us cycles, rises, collapses, and recoveries. It leaves us with the awareness that even if something extraordinary had taken place long before us, its signals might now rest in deep mud, waiting to be read, or already erased by the turning of the planet's crust. The oceans remind us that memory is layered, partial, and delicate. Their floor is not a library of clarity, but of fragments. Still, fragments are enough to remind us
Vastness, of continuity, and of the possibility that many chapters remain unseen. And in that thought, we can rest quietly, holding space for both the known and the unknown. What if the Earth itself were always erasing, smoothing, and reshaping, so that even great works or whole landscapes vanish as though they had never been? Erosion is the patient force behind this forgetting. It is the slow wearing away of mountains, the steady filling of valleys, the soft sanding down of coastlines. To us, it may look still, but in the measure of centuries and millennia, it is always moving. Rain, wind, rivers,
ice, each is a quiet sculptor. Together, they transform the surface so completely that once stood tall can become a plain, and what once was fertile land can disappear beneath desert or sea. Let us pause for a moment to picture how this unfolds. Imagine a city built of stone. At first, it looks firm, lasting, but water seeps into cracks. In winter, the water freezes and expands, pushing the stone apart. Wind brings dust that grinds at its edges. Plants take root, their roots prying walls open grain by grain. Within centuries, the outlines blur. Within millennia, the city is rubble covered by soil. In 10,000 years, there may be little more than faint patterns in the earth, lines too subtle to distinguish from natural formations. Over longer stretches, rivers shift course and wash the ground away, or glaciers sweep across, carrying everything with them. Erosion is not a single act, but a series of small, unrelenting gestures repeated until memory is gone. Now we can softly reflect on the limits this creates. When we search for traces of distant pasts, we are not searching a complete archive. We are walking into a library where many pages have been torn out, their words scattered by wind. The absence of ruins, of tools, of structures cannot be read as final proof that they never existed. It is often only proof that erosion has done its work. This is why humility is needed. The earth is not unkind, but it is restless. It does not hold on to the details we most wish to see. It remakes itself. Let us now imagine a small thought experiment. Suppose a civilization once built great dwellings along a fertile plain. Step 1. Over time, rivers flooded and shifted, washing away walls, burying foundations under silt. Step 2. Centuries passed. Forests grew and fell, their roots tearing apart the stones. Step 3. Ice sheets came, grinding the land down, leaving only smoothed rock. By the time the ice retreated, the plain looked fresh, as if untouched. To a future observer, there might be no sign at all. Only the chemistry of the soil, perhaps, or a subtle mix of minerals carried downstream would remain as an indirect whisper. And even those whispers might be indistinguishable from natural changes. Now we linger briefly on the language of erosion itself. In certain places, we can see unconformities, gaps in the rock record where time is missing, erased. A cliff might show layers hundreds of millions of years old, with younger rock resting directly above, as if entire ages had never happened. These gaps are reminders that memory is not only incomplete, but actively rewritten. What we do see is partial. What we do not see may be vast. For those who search, this means careful work with limited evidence. Each signal must be weighed, compared, and held lightly, knowing how easily it could have been lost. The silence of erosion does not tell us what never was. It only tells us what remains today. And so we drift toward a gentle conclusion. Erosion is the Earth's way of moving forward, always shaping, always renewing. It ensures that nothing on the surface is truly permanent. For us, it means that many stories, if they existed before, have been softened into absence. But absence is not certainty. It is simply the quiet space left when the Earth turns its own pages. In that quiet, we are invited to listen not only to what is present, but also to what may have been. What if the fires we kindle, the fuels we burn, are not only part of our present, but also quiet echoes of something that may have happened long ago? When we look closely, coal, oil, and natural gas are not ordinary materials. They are the compressed remains of forests, swamps, and tiny marine organisms that lived millions of years ago us. In their essence, they are stored sunlight, captured by plants through photosynthesis and buried under layers of rock. By burning them, we release that ancient sunlight back into the air as heat, as energy, as carbon. It is a cycle that feels natural to us, yet it leaves unmistakable marks, signatures that could be read by distant future eyes. Now we may gently pause to see how this process works. When plants die in wet, oxygen-poor places like swamps, they do not fully decay. Instead, layer upon layer of plant matter accumulates, pressing into peat, then into coal under the weight of time. In oceans, microscopic algae and plankton settle to the seabed when they die, mixing with mud, slowly transforming into oil and gas through heat and pressure. These reservoirs lie hidden until a civilization learns how to find and use them. When burned, the carbon stored inside them enters the atmosphere as carbon dioxide. This is a gas that mixes evenly across the sky, changing climate over decades and centuries. Such changes, though invisible in daily life, become etched into the Earth's chemical memory. Ice cores, sediments, and even stalactites in caves carry the imprint of these shifts. Scientists can read these imprints thousands of years later, much like faint fingerprints left on glass. Now we can stay for a moment with what this means. If an earlier society had burned large amounts of fossil fuels, they too would have left signals. A sudden rise in atmospheric carbon, perhaps, or altered ratios of isotopes, carbon atoms of slightly different weights. These isotopic shifts are especially telling because carbon from fossil fuels has a distinct signature, lighter than the carbon in the air or plants today. Once released, it changes the overall balance, and that change is recorded in ice, in shells, in sediments. Even if every city crumbled, the chemistry of the air would remain as a whisper in the archives of nature. Yet there are limitations. Over millions of years, signals blur. Ice melts, sediments are disturbed, ocean floors are recycled back into the mantle of the Earth. The record grows faint, and patterns can be explained by natural processes too: volcanoes, methane releases, even large forest fires. This is why scientists are careful, distinguishing between what is unusual and what is simply part of Earth's own rhythms. The absence of clear evidence of earlier burning does not mean it never occurred. It only means we cannot see it through the fog of time. Let us imagine, softly, a thought experiment. Step 1. A civilization millions of years ago discovers coal, burns it widely, altering the climate. Step 2. Their presence fades, but the spike in carbon is locked in sediments at the bottom of ancient lakes. Step 3. Millions of years pass, and those sediments are buried, folded, or eroded. Some survive as thin bands of chemical change. Much later, another civilization, ours, arrives and studies them. Would we recognize the signal as human, or would we assume it came from natural forces? The line between the two may be subtle, blurred, requiring humility in how we read it. Now we can notice gently that fire itself is both ancient and universal. Long before fossil fuels, humans learned to control wood fires, changing landscapes by burning fields and forests. This too leaves traces: charcoal in soil, black bands in sediment. Charcoal is surprisingly durable, sometimes lasting tens of thousands of years. If others before us learned to use fire broadly, their legacy might be preserved as layers of dark dust, thin but persistent, silent hints of intention. And yet, as with all such traces, interpretation is delicate. Nature too produces fires, lightning igniting forests, lava setting plains alight. We cannot always know whether a layer of charcoal marks
Accident, climate, or deliberate action. What we are left with is a balance of possibility. The fuels we burn today show us how civilizations inscribe themselves into the planet. The carbon we release, the ash we spread, the soot we deposit, all become quiet entries in Earth's archive.
If we see such entries in deep time, we cannot easily say who or what wrote them. We can only acknowledge that something unusual happened and let the question rest open. In this way, fossil fuels and fire remind us of both power and impermanence. They show us how energy shapes worlds, but also how signals fade into ambiguity. The Earth holds memory, but softly, imperfectly, always blending voices together. And so we are left with a gentle thought. The fires of the past, whether natural or human, are not gone. They continue as whispers in the record, faint signals waiting to be read, even if their authors remain unknown. What if the fingerprints of industry are not only visible in the world we see today, but also pressed quietly into the planet's long memory? Factories, mines, refineries, power plants. They feel recent, yet their effects extend beyond our time. Smoke from chimneys becomes particles that drift into the sky, then settle into snow and ice. Plastics break down into small fragments and sink into oceans. Nuclear tests leave atoms that behave unlike anything found naturally. These traces are not fragile in the same way as stone buildings or steel bridges. They can persist, sometimes for thousands, even millions of years. Now we may pause gently to see how these processes unfold. When coal and oil are burned, tiny bits of ash and chemical byproducts rise into the atmosphere. Some return to the ground, washed down by rain. Others are carried to the poles, where they are sealed into layers of ice. Later, scientists drilling deep cores can measure spikes of lead or sulfur that match times of intense human activity. These are like quiet timestamps pressed into nature's own archive. Plastics offer another kind of marker. Born only in the past century, they already fill rivers, beaches, and oceans. Sunlight and waves break them into particles too small to see, yet they do not vanish. They blend with sand, mix into sediments, and settle on the seafloor. In the far future, a thin layer of strange synthetic fragments may mark this era, just as ash layers mark ancient eruptions. Now let us softly linger on something less visible. Nuclear activity, though brief in human history, leaves isotopes, forms of atoms with unusual weights that do not occur naturally in such abundance. Some of these isotopes decay quickly, others last for tens of thousands of years. They are found in soil, in rivers, in sediments carried to the ocean. If another being were to study Earth long after us, such isotopes would be a clear signal that something unusual, something technological, once shaped the planet. Yet, as always, there are limits. Geological processes blur signals over long spans of time. Sediments are disturbed, ice melts, rocks are recycled back into the Earth's deep layers. Plastics may be altered, radioisotopes may fade. Over millions of years, clarity dissolves, and what remains may be ambiguous. We cannot know for certain how much of our industrial fingerprint will persist, nor how it would be read. Absence in the record would not mean absence of the event, only the success of the Earth's erasing hand. Let us try a gentle thought experiment. Step 1. Imagine our age passes, and all our cities crumble. Step 2. Centuries later, forests grow where highways once stretched. Seas reclaim coastal towns. Wind smooths the ruins. Step 3. Sediments settle on top, sealing fragments of plastic, glass, and concrete. In thousands of years, only these layers remain, pressed flat, hidden beneath soil. A million years later, perhaps only unusual minerals, faint chemical changes, or scattered isotopes would survive, the cities themselves long gone. To whoever might study that layer, it would be a signal, but not a story. Interpretation would be cautious. Myth and research would be open.
Never certain. Now we can briefly return to the idea of industry as both fleeting and enduring. Machines rust. Buildings collapse, yet chemistry and physics record their presence in quiet ways. Just as volcanic eruptions leave ash bands or asteroid strikes leave iridium-rich layers, so too does human activity create thin lines in the Earth's archive. The scale is modest compared to geological forces, but it is distinct. The Earth notices in its own slow way. And so we reach a gentle pause. The scars of industry remind us that while our structures vanish, some signals outlast us. They may persist as whispers in stone, in ice, in sediment. Whether they are ever read or ever understood, we cannot know. But their existence suggests that traces of earlier humanities, if they ever were, might also have been written in chemistry rather than in monuments. The Earth holds such secrets softly, blending them with its own rhythms, leaving us with possibility rather than certainty. What if the scattered objects we sometimes uncover, those that puzzle archaeologists and spark quiet debates, are not only fragments of known cultures, but also faint reminders of something older, something beyond the records we hold? Across the world, discoveries appear from time to time. A shaped stone whose purpose is unclear, a shard of metal fused with rock, a tool-like form found far outside the timeline we expect. Most of these, upon careful study, find their place within ordinary explanations. Natural forces can mimic human design, and known societies can account for surprising finds. Yet a few remain ambiguous, leaving a space for wonder. Now let us pause softly and think about how these objects come to us. The Earth is restless. It buries, folds, erodes, and reveals. Sometimes riverbanks collapse and expose bones or tools. Sometimes mines or quarries bring to light what lay hidden for ages. Even a farmer's field can produce an unexpected object. But the survival of artifacts is rare, depending on chance. Most materials decay long before they can be discovered. Wood and fabric vanish quickly. Metal corrodes. Even stone can fracture and crumble. What survives does so because conditions happened to favor preservation. A sudden burial, a protective layer of sediment, a dry cave, or a deep layer of clay. This rarity is important to remember, for it means the record is not complete, but heavily filtered. Now we can linger for a moment on the limits of interpretation. Archaeology relies on context. A shard of pottery in the ground is only meaningful when connected with the layer of soil around it, with nearby remains, with the story of the site as a whole. When context is lost, when an object is found alone, without surrounding data, its meaning is uncertain. It may be misdated, misplaced, or misunderstood. This is why extraordinary claims must be treated with care. A shaped stone could be an unusual product of natural fracture. A metal piece could be slag from smelting, rather than evidence of advanced technology. The absence of full context leaves room for speculation, but not for certainty. Still, such puzzles remind us how fragile our knowledge is, how easily records can vanish. Let us try a simple thought experiment. Step 1. Imagine a small community long ago shaping tools from a local mineral not usually used. Step 2. Over thousands of years, their settlement disappears, buried under soil. Step 3. Erosion exposes a single tool, which is found by chance. Without context, without companions, it seems out of place. To later eyes, it may look inexplicable. The truth is lost, and all that remains is a solitary object, ambiguous and open to interpretation. We can also note the indirect language of artifacts. Even when objects themselves vanish, they can leave imprints. A post may decay, but its whole remains as a darker stain in the soil. A fire may fade, but charcoal persists, its black fragments visible centuries later. A workshop may be gone, but slag, the waste of smelting, can endure. These indirect traces
often tell us more than the objects themselves, because they reveal processes, not just outcomes. And yet, even they are incomplete. The soil does not record intention, only presence. The boundary between natural and human can blur. We cannot always know.
Now, before we move further, we can gently return to humility. When we encounter puzzling artifacts, we face the limits of evidence. Most turn out to have ordinary explanations. A few remain unsettled. None prove a forgotten civilization, yet none can entirely erase the possibility. What they truly offer is perspective, a reminder that our knowledge is partial, that the Earth's archive is selective, that chance governs much of what we recover. And so we arrive at a quiet pause. The puzzle of artifacts is less about certainty and more about openness. Each find is a fragment, sometimes clear, often blurred. Together, they form a story that is incomplete but suggestive. The silences between them are as meaningful as the objects themselves. In those silences, we hold the possibility that more may have existed than we can now see, and that the Earth has kept most of its secrets to itself. What if the great extinctions we see in the fossil record, those sudden vanishings of countless species, were not only the result of natural catastrophes, but also shaped, at least in part, by the actions of beings we no longer remember? When we look at the layers of rock, we sometimes find abrupt boundaries. Below them lie rich ecosystems, full of variety. Above them, many forms of life are missing. The most famous example is the line marking the end of the dinosaurs, where iridium-rich dust and shocked quartz suggest an asteroid impact. But not all extinctions have such clear causes. Some unfold more quietly, over thousands of years, yet still leave sharp edges in the fossil record. Now, let us pause and reflect on what these boundaries mean. Extinction is a natural process. Species appear, flourish, and disappear even without dramatic events. Climate changes, continents drift, oceans open and close. Yet, there are times when the loss is sudden, too broad to be explained by ordinary shifts. Whole families of creatures vanish, leaving behind a silence in the layers. Scientists search for causes: volcanic eruptions, asteroid impacts, changes in ocean chemistry. Often, the evidence points to such natural explanations. Still, we cannot rule out other possibilities, for absence of evidence is not evidence of absence. Let us think gently about how human activity today leaves its own mark. Our hunting pressures, our land use, our alteration of climate all contribute to what many call the sixth extinction. Species vanish faster than the natural background rate. If another species were to study Earth millions of years in the future, they might see our time as a sharp boundary, a sudden thinning of biodiversity, followed by a recovery of new forms. They might wonder what agent caused it. Would they see the signals of climate change, of chemical alteration, of carbon spikes in sediments? Would they suspect a civilization? This thought allows us to imagine how past extinctions, unexplained in detail, could also raise quiet questions. Now, let us linger briefly on the language of the rocks. Extinctions are marked by fossil counts that suddenly decline, by pollen grains that disappear from sediments, by shifts in isotope ratios that reveal altered food webs. These are indirect markers, statistical shadows of vanished life. They do not name the cause, but they show the effect. Sometimes the cause is clear, a layer of volcanic ash, a chemical spike of iridium. Sometimes it is not. The ambiguity leaves room for speculation, but not for certainty. To see this more clearly, let us try a thought experiment. Step 1. Imagine a civilization millions of years ago, hunting large animals, altering landscapes, burning forests. Step 2. Species decline, their absence recorded in the layers of soil and lake beds. Step 3. The civilization itself vanishes, but the fossil record keeps the signal of extinction. Later, another species studies the layers and finds a sudden loss, but not the cause. They may assume climate or volcanism, unaware of the hands that once shaped it. This experiment reminds us of humility. We can observe effects, but causes may remain hidden forever. Before we move further, we can note that natural processes themselves often mimic deliberate ones. Climate can warm quickly, glaciers can retreat, oceans can acidify. all without human or human-like agents. To separate natural from deliberate is often beyond reach. What we can say is that extinction leaves marks, sharp and lasting, in the planet's memory. And so we come to a gentle pause. The great extinctions are reminders that the Earth's history is punctuated by loss and renewal. Whether caused by asteroid, volcano, climate, or something we cannot yet see, they leave unmistakable gaps in the story of life. They are signals of change, but not of certainty. In their silence, we are invited to accept the limits of knowledge, to honor the vastness of time, and to keep open the possibility that many forces, natural and perhaps once human, have shaped the record we now read. What if the ice itself, clear and quiet, is not only frozen water, but also a library, holding delicate memories of the air that once surrounded this planet? In the deepest glaciers, far from warmth, snow has pressed down over centuries, layer upon layer, each winter sealing in bubbles of atmosphere, grains of dust, traces of ash, faint marks of what the sky once carried. These layers, like pages in a fragile book, allow us to travel backward in time. By drilling deep into ice sheets, scientists can read the composition of ancient air, as if listening to whispers caught and preserved. Now, we may pause softly to see how this process works. When snow falls, it traps small amounts of air between the crystals. Over time, as more snow covers it, pressure increases, and the snow compacts into firn, then into glacial ice. The tiny air bubbles become sealed, isolated from the present atmosphere. Within them are the exact proportions of gases, oxygen, carbon dioxide, methane, from the moment they were trapped. Alongside them, dust grains show wind patterns, volcanic ash reveals eruptions, even faint traces of lead or other pollutants record human activity. In this way, ice becomes a timeline, a record stretching back hundreds of thousands of years. Yet there are limits to what it can tell. Ice is not eternal. It melts, flows, and eventually disappears. Even the oldest surviving ice, about 800,000 years old, is but a brief span compared to the age of Earth. Beyond that, the archive dissolves. Memory is erased, leaving only fragments. We cannot know directly what the air was like millions of years ago, nor can we see beyond the range that glaciers preserve. The silence beyond this boundary does not mean nothing happened, only that the pages have been lost. Now let us linger for a moment on what the ice has already revealed. In cores taken from Antarctica and Greenland, we see cycles of ice ages and warm periods, marked by the rise and fall of carbon dioxide. We see sudden spikes of methane, hints of abrupt climate shifts. In more recent layers, we see the fingerprints of human industry, lead from gasoline, soot from coal burning, radionuclide testing. Each appears as a thin line, a delicate marker, preserved as clearly as ink on paper. These markers remind us how much of our presence is written into the air itself. Let us try a quiet thought experiment. Step 1. Imagine a civilization long before ours, burning fuels or reshaping land, altering the composition of the atmosphere. Step 2. Their changes become sealed in bubbles of ice, just as ours are today. Step 3. Millions of years pass, and the ice melts, flows into the sea, erasing the record. To later eyes, their presence would vanish. Only if fragments of ice remained in protected valleys, or if sediments elsewhere captured their chemical signals, might whispers survive. This possibility reminds us how fragile even the best archives can be. Now we can pause on the indirect language of isotopes. The balance of oxygen isotopes in ice tells us about past temperatures, because lighter and heavier forms of oxygen evaporate and condense differently depending on climate. Carbon isotopes reveal the sources of carbon dioxide, whether from volcanoes, from living forests, or from fossil fuels. These subtle signals are durable, precise, but also open to interpretation. They tell us about change, but not always about cause. We read them cautiously, with humility, and so we drift gently to a conclusion. Ice is a remarkable library, yet a temporary one. It holds voices from the last 100 millennia with clarity, But beyond that, it falls silent. Its record shows us cycles, crises, and human fingerprints, but it cannot tell us whether earlier ages held similar signals. What we have is precious, but also partial. The ice teaches us to listen carefully, to value what survives, and to accept that much is already gone. In its quiet memory, we see both the strength and the fragility of Earth's archives. And we are reminded that silence is not absence, only the soft closing of pages we can no longer read. What if many stories of the past are hidden not on dry land, but beneath the waves, where coastlines have shifted again and again? The sea is never still on the scale of deep time. Levels rise, levels fall. Ice ages lock water into vast glaciers, lowering oceans by hundreds of meters. Warmer ages melt the ice, sending seas forward, drowning valleys, plains, and river mouths. What seems permanent to us, a beach, a harbor, a fertile shoreline, is in truth only a temporary edge, changing shape with each turning of climate. Now let us pause gently to imagine the scale. During the last ice age, much of the water was locked into thick ice sheets. Sea levels stood far lower than today. Lands now submerged were broad plains, with rivers winding across them, forests spreading, perhaps even people walking where waves now roll. As the climate warmed, the ice retreated and the seas rose. Whole landscapes disappeared, leaving no trace above the waterline. Today, scientists mapping the seafloor find ghostly outlines. River channels cut into stone, drowned forests preserved in mud, traces of ancient shorelines lying deep below the surface. These are quiet reminders that the world we know is only one version among many. Now we can linger for a moment on the limits of knowledge. Most archaeology takes place on land, where excavation is possible. Underwater, the work is harder. Sediments cover remains, currents shift the seabed, visibility is low, and access is costly. Much of the submerged world has never been studied. We cannot know what rests beneath silt or sand, and we may never uncover it. The absence of discoveries there does not mean absence of life or culture, only that our access is narrow. Still, we have hints. Off the coasts of Europe, Asia, and the Americas, divers have found submerged tools, hearths, and settlements. In some places, tree stumps stand preserved under saltwater, their roots still anchored in ancient soil. Caves now filled with water hold paintings and carvings that once were above the sea. Each of these is a fragment of memory, showing how rising waters erased landscapes, but not entirely their stories. Now let us softly imagine a thought experiment. Step 1. Suppose a community once lived on a coastal plain, farming and building along riverbanks. Step 2. Over centuries, the ice melts, seas rise, the plain sinks below waves. Step 3. Sediments settle over the remains, sealing them in quiet darkness. Thousands of years later, only divers or sonar can detect the shapes. And millions of years later, the seabed itself may shift, carrying the memory into deep geology. Such a path shows how fragile coastal records are, and how easily they can slip from reach. We can also pause on the indirect markers. Marine sediments capture pollen grains washed from land, showing what plants once grew along vanished coasts. Isotopes in shells record changes in temperature and salinity, hinting at when seas advanced. Layers of sand within cores reveal storms and floods. These signals do not tell us directly about people, but they tell us about the environments people may have inhabited, now hidden below the waves. They are whispers of context, not of presence, but even that context is valuable. And so we arrive at a quiet conclusion. Coastlines shift, and with them, much of human memory shifts too. What once was home may now be seafloor. What now is land may one day be drowned. The ocean keeps its secrets well, storing them under silt and tide. We cannot say with certainty what has been lost there. We can only know that much has been hidden, perhaps forever. The drowned coasts remind us that history is not only buried in soil and stone, but also in the restless margin between land and sea, where time erases gently and the silence of absence leaves room for possibility. What if the rhythm of civilizations, whether ours or imagined ones before us, has always been tied to fire in its many forms? Fire is both simple and profound. It begins with the burning of wood, giving warmth and light. Later it moves to coal, oil, and gas, fossilized energy drawn from deep time. Eventually, it reaches the hidden forces of the atom, where nuclear reactions release power from the smallest structures of matter. Each stage feels like progress, yet each leaves behind quiet marks, traces in the air, the soil, the stone. These traces are not only of energy itself, but of the consequences of using it. Now let us pause gently to think of how this cycle works. Wood burning leaves charcoal, a black and fragile residue. Coal burning fills the atmosphere with carbon dioxide, a gas that mixes evenly through the sky. Oil and gas release not only carbon, but also subtle chemical byproducts, such as sulfur or nitrogen compounds. Nuclear reactions create isotopes, atoms with unusual weights, that linger far longer than smoke or ash. Each of these is a signal written in the Earth's archive. Charcoal survives in soil and sediment. Carbon dioxide leaves its fingerprint in the isotopic ratios of air and ocean. Isotopes from nuclear activity rest in soils and drift into ice, where they can persist for tens of thousands of years. These signals together become the language by which energy use is recorded, whether intended or not. Now we can linger briefly on the limitations. Signals fade. Charcoal layers may be reburied, eroded, or washed away. Carbon signatures may be blurred by natural processes, volcanic eruptions, methane releases, long climate cycles. Isotopes eventually decay, their signals growing weaker with time. Over millions of years, much of this record may dissolve, leaving only faint hints. We cannot assume that silence means nothing occurred. It may simply mean that time has erased more than it preserved. Let us imagine a thought experiment, carried softly through 3 steps. Step 1. Picture a civilization learning to burn coal on a wide scale, raising smoke into the air, shifting the balance of gases in the atmosphere. Step 2. Centuries later, sediments at the bottom of lakes and seas record this shift as altered isotopes, as particles of ash, as traces of heavy metals. Step 3. Millions of years pass. The civilization vanishes, the land changes, yet the sediments remain, buried, pressed into stone. A thin layer rich in carbon and ash lies hidden, indistinguishable at first glance from volcanic deposits, but perhaps carrying subtle differences that whisper of deliberate fire. The thought does not claim certainty, only possibility. Now we may return to the broader rhythm of fire. Each energy source brings not only benefits, but vulnerabilities. Wood leads to deforestation. Coal and oil lead to climate shifts. Nuclear energy carries risks of contamination. These are patterns we know well from our history. If others before us had followed similar paths, the echoes of their choices might still rest quietly in the archives of nature. And yet, as we
Remind ourselves, the Earth is a restless keeper of memory. It folds, erases, and rewrites its own record. The traces may be subtle, fragile, or gone. The absence of clear evidence is not a verdict. It is only silence. And so we arrive at a gentle conclusion. The cycle of fire, in its many forms, is both a tool of growth and a potential signal that outlasts its makers. It is written in charcoal, in isotopes, in subtle shifts of chemistry. Whether it speaks of us alone or of others before us, we cannot say with certainty.
What we can say is that energy leaves marks, and those marks remind us that civilizations inscribe themselves not only in monuments and stories, but also in the very elements of the earth. In that awareness, we find humility, and in humility, we find rest. What if the tools we use to look into the past, careful and precise as they are, still allow us to see only a fraction of what has been? Archaeology is the patient craft of uncovering traces left in soil and stone. Yet, by its nature, it is limited. We dig in places we can reach, places chosen by chance or by hints from the surface. Most of the earth remains untouched. Entire continents have layers we have never studied, layers that may hold secrets but are buried deep, hidden under cities, forests, deserts, or oceans. We can think of it as searching through a vast library where we have opened only a handful of books, and even those books are incomplete, with many pages missing. Now let us pause gently to see how this record is created. When people live in a place, they leave traces, hearths of stone, fragments of pottery, seeds, bones, or tools. Over time, these traces are covered by soil, sometimes preserved, sometimes destroyed. Archaeologists uncover them by digging carefully, layer by layer. Context means everything. The depth at which an object lies, the layers above and below it, the other remains found nearby. Without context, even a striking artifact may lose its meaning. A shard of pottery alone cannot tell us its age or its use. It is the surroundings that give it voice. But context is fragile. Erosion, flooding, construction, and even time itself can erase it. That is why much of the record is fragmented, like a puzzle with most pieces missing. Now we can linger for a moment on what is beyond reach. Most of the Earth's history lies far deeper than archaeology can touch. The layers we excavate usually go back thousands of years, sometimes tens of thousands. Rarely do we reach hundreds of thousands. Beyond that, evidence becomes geological rather than archaeological, locked into rock rather than soil. If civilizations rose and fell long before us, their traces might now be pressed too deep for our tools to uncover. Our methods were not designed to search for what might lie millions of years behind. They focus on the recent, the humanly possible, not the speculative. Yet this does not mean older stories never existed. It means only that our tools and perspectives are tuned to a narrow band of time. Let us try a thought experiment. Step 1. Imagine that a community once thrived 50,000 years ago, building dwellings of wood, weaving fiber, leaving few stone traces. Step 2. After their disappearance, forests grew, rivers shifted, soil buried what remained. Step 3. Tens of millennia later, only faint soil discolorations or scattered bones survive, unrecognizable without context. To us, their world might be invisible, even though it once was real. This experiment shows us the delicacy of the record and how easily it can fade beyond recognition. Now we can return to the indirect language archaeology sometimes offers. Even when no artifacts remain, the soil itself may carry clues. A darker patch may mark an ancient fire. Seeds preserved in waterlogged layers can reveal crops once grown. Microscopic wear on stone tools may show what materials they worked. These are small signals, read with care. They remind us that the past speaks in quiet, subtle tones, not in loud declarations. Yet they also remind us how much may go unheard. Before we move further, let us reflect on humility. Archaeology has transformed our understanding of humanity in just a short time. Cities once forgotten, like Troy or Mohenjo-Daro, have been brought back into memory. Whole civilizations unknown a century ago are now studied in detail. And yet, these discoveries are recent, fragile, dependent on chance finds. How much more, then, may remain unseen, hidden under deserts, mountains, or seas? We cannot claim completeness. We can only work with what we have. And so we drift to a gentle conclusion. The limits of archaeology remind us that silence in the record is not proof of absence. It is only a measure of what we have not yet touched, or what time has already erased. The earth is vast, its archives scattered and fragile. We walk through them slowly, turning fragments into stories. But beyond what we hold lies an expanse of unknown pages, perhaps forever unread. In that quiet space, between what is known and what is lost, rests the possibility that more once was, and the acceptance that much will never return. What if the question of past civilizations is not about certainty, but about probability, about the quiet balance between what we might expect to see and what the earth chooses to preserve? When we think in human lifetimes, evidence feels solid. Ruins stand, books endure, metals shine. But when we stretch our view to tens of thousands, to millions of years, we must accept that almost everything dissolves. What remains are fragments, signals, scattered markers. And so, the absence of evidence is not an answer, but part of the landscape of deep time. Now we may pause to understand this more closely. Probability here does not mean a number, but a gentle weighing of likelihoods. It is probable that stone tools endure longer than wood. It is probable that chemical signals in sediments outlast buildings. It is improbable, though not impossible, that complex structures remain untouched after millions of years. This way of thinking guides our search. We do not look for certainty, but for signs that might suggest more than nature alone. Yet even with this approach, the earth is a selective archivist. It keeps some lines, erases others, and leaves gaps too wide to fill. Let us linger a moment on the mechanisms that shape these gaps. Erosion scrapes layers away. Volcanoes bury and transform. Oceans drown coasts and recycle their floors. Ice sheets grind and reset the land. Each process is natural, slow, and thorough. Together, they ensure that the deeper we look, the fewer intact traces we find. If earlier civilizations had existed, the chance of recovering clear artifacts is small. What is more likely is the survival of indirect evidence, shifts in chemistry, patterns in isotopes, sudden changes in sediments. But even these may be blurred, reinterpreted by nature's hand. This is why probability is our companion, not certainty. Now let us imagine, softly, a thought experiment in 3 steps. Step 1. Suppose a civilization thrived 500,000 years ago, using materials much like ours. Step 2. Over time, its buildings eroded, metals rusted, and forests grew over its remains. Step 3. Through glaciations, floods, and tectonic shifts, almost all physical traces vanished. What would remain might be only a faint chemical anomaly in sediments, a subtle shift in carbon isotopes, or an unusual concentration of particles that resemble industrial ash. To us, this would be nearly invisible, perhaps dismissed as natural. The probability of recognition is slim, even if the civilization once existed. And yet, we must pause here to remind ourselves of scientific humility. The fact that something is unlikely to be preserved does not mean it never was. The Earth's silence is expected, its erasures predictable. We work within those constraints, but we do not mistake them for final judgments. We read carefully, always aware of the gaps. Now we can linger on the language of signals that endure longer than structures. Carbon isotopes, trapped in shells and ice, reveal the balance of gases.
Long after buildings are gone, heavy metals in soils can mark episodes of smelting or burning. Charcoal layers may suggest large-scale fire. Each is a quiet marker, none conclusive on its own. Together they form patterns, and patterns give us probabilities. But probabilities are not proof. They are suggestions, reminders of possibility, open to more than one interpretation. And so we drift to a gentle conclusion. The weight of probability leans toward silence, toward erasure, toward the fragility of traces. But within that silence, there is space. Space for humility, space for imagination, space for the acceptance that absence is not absence of being, only absence of preservation. What we hold, then, is not certainty, but balance, a quiet awareness that the earth has lived many ages, and that what survives from them is only the smallest fraction. In that awareness, we may rest, listening not only to what is present, but also to what might have been, somewhere beyond the reach of evidence, in the long memory of time. What if the myths we carry, the old stories whispered across generations, are not only symbols, but also softened memories of events long past? Myths of floods, of golden ages, of worlds lost and rebuilt, appear in cultures far apart, separated by oceans and centuries. They echo one another, like faintly repeated songs, though told in different languages and framed in different images. We often read them as metaphors, teaching lessons about order and chaos, about human frailty and resilience. Yet we can also pause to consider whether some part of them preserves a distant memory, distorted but not entirely invented. Now let us softly linger on what a myth is. A myth is not a record in the way a chronicle is. It does not count years or names precisely. Instead, it condenses experience into story. Floods become tales of gods washing the world. Fires become punishments from the sky. The end of one age and the start of another becomes a cycle of golden, silver, or iron worlds. Myths are like clouds, shaped, reshaped, carried by winds of culture, yet often arising from something real beneath. In this way, they may contain fragments of memory, though blurred. We must approach them with humility, never certain where history ends and imagination begins. Now we can pause briefly on the flood motif, perhaps the most common. Many cultures tell of a great flood that drowned lands, sparing only a few. In Mesopotamia, in India, in the Americas, in Polynesia, in Northern Europe, the pattern recurs. Science tells us that at the end of the last ice age, seas rose quickly, sometimes swallowing whole coastal plains within generations. To those who lived there, such floods would have seemed like the end of the world. Memory of such events, carried in story, could easily last thousands of years. We cannot prove the connection, but the resonance is strong. A myth may not be a precise record, yet it can hold a kernel of remembered truth. Let us imagine, gently, a thought experiment. Step 1. An ancient community experiences a sudden catastrophe, a flood, a great fire, or the fall of a settlement. Step 2. Survivors tell the story to their children, giving it meaning, weaving it into symbols. Step 3. Centuries pass, and the story is retold, reshaped, adjusted to new listeners. After 1,000 years, the details fade, but the core remains. A world destroyed, a few saved, a lesson carried forward. To us, it arrives as myth. To them, it began as memory. This experiment shows how fragile events can persist through imagination, not through stone. Now we may reflect on the indirect markers myths leave in the record. Archaeologists sometimes compare stories to evidence. If a myth speaks of a flood, and geological cores show sudden flooding in the same region, the two together gain weight. If a story speaks of fire from the sky, and a layer of ash or impact debris is found nearby, we see echoes. The myth does not prove the event,
nor the event the myth, but the parallel suggests that memory and geology sometimes walk together. Still, there are limits. Not all myths can be tied to events. Some are purely symbolic, born of imagination and belief. Others may merge many memories into one story. We cannot separate them cleanly. The silence of evidence remains. The presence of myth alone cannot serve as proof. Yet, as with so much in deep time, absence of certainty does not erase possibility. Before moving further, we can pause to notice the role of myth in connecting us to time. While stones preserve fragments, stories preserve emotions. Fear of water, awe of fire, the sense of cycles. These are carried in human voices, perhaps echoing across ages we can no longer measure. Even if the stories are not history, they remind us of the fragility of memory and of how experience survives when written not on tablets but in hearts. And so we drift toward a gentle conclusion. Myths are not clear records, but neither are they empty. They are shadows, sometimes aligned with real events, sometimes only reflections of thought. Whether they preserve traces of earlier humanities or only the cycles of our own, we cannot say. What we can say is that they form part of the great archive, as valid in their own way as stone or ice. They show us that memory can endure not only in matter, but in imagination, carried softly across the span of generations. And in that awareness, we may rest, accepting both the uncertainty and the beauty of stories that reach beyond the grasp of history. What if the sky itself, vast and constant above us, holds quiet reminders of events we can barely imagine? Celestial impacts, asteroids or comets striking the Earth, are rare on human scales, but across millions of years they are inevitable. Each leaves a scar, sometimes visible as a crater, sometimes hidden under oceans or jungles, sometimes erased by erosion. More than scars, they also leave signals. Thin layers of debris scattered worldwide, fragments of glassy rock formed in the heat of impact, tiny spherules that settle into sediments like dust from a distant fire. These are the subtle footprints of the cosmos, pressed into the Earth's record. Now let us pause gently to see how this process unfolds. When a large body strikes the Earth, the force is immense. Rock melts, vaporizes, and spreads into the atmosphere. Some of it rains down as small glass beads. Some of it mixes with the air, forming chemical traces. Even if the crater itself vanishes over time, the layer remains, sealed into soils, into lake beds, into ocean floors. Scientists study these layers, identifying elements like iridium, which is rare on Earth but common in asteroids. A sudden spike of iridium across the globe tells of an impact, even when no crater is found. The most famous example is the event that marked the end of the dinosaurs 66 million years ago. Yet smaller, quieter impacts have also occurred, leaving thinner traces, less understood, but still there. Now we can linger briefly on the limits of knowledge. Not every layer is preserved. Oceans recycle their crust. Erosion wears down land. Many impacts, even large ones, may leave no visible mark today. Others may be buried too deep for us to find. What survives is only a fraction. And within that fraction, we cannot always separate natural impact signatures from other causes. Volcanic eruptions, for instance, also scatter ash rich in unusual elements. Fires can also darken sediments. The signals overlap. We must read them with caution, always aware that absence of proof does not prove absence of event. Let us try a thought experiment, gentle and slow. Step 1. Imagine a great impact, striking Earth during an age when a civilization flourished. Step 2. The impact devastates regions, shifts climate, and leaves behind its chemical signature. Step 3. Millions of years pass. The civilization itself is gone, its traces erased, but the impact layer remains. To later scientists, the layer is clear, but the human presence connected to it has vanished entirely. The record shows a natural catastrophe, but not the lives entwined with it. This thought reminds us how easily context is
Lost. How fragments of truth survive while others dissolve. Now we may turn to the language of sediments. In deep ocean cores, thin bands mark sudden disturbances. Layers rich in spherules, shocked minerals, or soot. Some bands align with extinctions, others with abrupt climate change. These are not full stories, but bookmarks, silent reminders that something sudden happened. Whether natural alone or overlapping with human or human-like presence, we cannot know. We only see the mark, not the full hand that pressed it. Before moving further, we can pause to note how celestial impacts remind us of scale. They are rare on the span of centuries, but over millions of years they shape life itself. They are part of the planet's rhythm, indifferent to civilizations. If others rose before us, they too would have faced the same sky, the same risks, the same unpredictable visits from beyond. And so we arrive at a quiet conclusion. The traces of cosmic impacts are durable, yet incomplete. They show us that sudden events can leave global markers, even as all else fades. But they also remind us that markers tell only part of the story. They cannot tell us who watched the sky darken, who feared, who endured, who disappeared. They are signals without voices, leaving us with possibility, with humility, and with the gentle acceptance that some truths may remain forever beyond reach. What if the quiet layers of volcanic ash spread thinly across the world are not only reminders of nature's own force, but also silent chapters where civilizations may have vanished, leaving no other trace but the soot of their final days? Volcanic eruptions are among the most powerful events the Earth produces. They bury landscapes under ash, change climates for years, and reshape coastlines. To us, they are sudden, overwhelming. But in the long measure of time, they are also record keepers. Their ash settles in lakes, in ice, in ocean floors, forming thin, distinct lines that can last for millions of years. These lines are called tephra, and they act like bookmarks in the Earth's history, telling us that something explosive once occurred. Now let us pause to consider how these signals work. Each eruption scatters material with a unique chemical signature, almost like a fingerprint. By studying tiny grains of ash in distant sediments, scientists can trace them back to their origin. When the same layer appears across regions, it becomes a marker of time, helping us align histories of climate, fossils, and even human activity. For example, the eruption of Toba about 74,000 years ago left ash across much of Asia. Ice cores and ocean sediments show its signal clearly. Some researchers suggest it caused a dramatic cooling, perhaps stressing early human populations. Others argue the effects were less severe. The uncertainty remains, yet the ash line is undeniable, a clear reminder of a sudden and global event. Now we can linger gently on the limits of what we know. Ash tells us that an eruption happened, and roughly when. It does not tell us who lived nearby, or how they endured, or whether they vanished. Archaeological sites buried under volcanic layers, like Pompeii, are rare gifts. Most of the time, cultures erased by eruptions leave little behind. Buildings burn, fields are covered, people scatter. What we recover centuries later is fragmentary at best. The record is therefore uneven. We must remember that the silence of ash does not mean silence of life. Let us try a thought experiment. Step 1. Imagine a small civilization thriving near fertile volcanic soil. Its people farming, building, trading. Step 2. A great eruption occurs, burying the land in meters of ash, altering the climate, scattering survivors. Step 3. Thousands of years later, the ash layer remains, clear in sediments. The civilization itself, however, is gone, without trace, its artifacts eroded or buried too deep.
To us, the story appears as only a thin gray line, without voices, without names. This thought shows how eruptions can erase cultures, leaving nothing but a chemical signal. Now we may turn to the language of the sediments themselves. In ice cores, volcanic layers appear as spikes in sulfur. In lakes, they appear as pale streaks between darker muds. In the ocean floor, they form distinct horizons that scientists can date with precision. These are global markers, helping us synchronize timelines across distant archives. Yet, they are also reminders of fragility. What is preserved is not the people, but the disaster. The survivors' voices vanish, while the ash endures. Before we move further, let us pause to notice the scale. Large eruptions are rare on human timescales, but across millions of years they are many. Some may have influenced evolution, others migration, others collapse. If civilizations older than ours had risen near volcanoes, their end may be written only as an ash band, indistinguishable from the many others. We cannot separate one story from another. All we see are lines, silent and equal. And so we drift toward a quiet conclusion. Volcanic ash is both a gift and a limit. It preserves a clear signal of when the Earth shifted suddenly, yet it hides the lives entangled with that shift. It reminds us that civilizations, if they existed, may have been erased in ways we cannot now discern. What we hold are layers of dust, durable yet voiceless, pointing not to certainty but to possibility. In their quiet, we are invited to accept both the strength of nature's record and the fragility of human memory. What if climate itself, with its long rhythms and sudden turns, has been both the maker and the eraser of civilizations? Climate is not steady when measured across centuries and millennia. It swings, sometimes slowly, sometimes abruptly. Ice advances, then retreats. Deserts expand, then shrink. Rainfall for centuries, then fails for generations. For us, these changes are background, but for people living through them, they can mean the difference between growth and collapse. And yet, climate also leaves records of its own, marks that we can read, in ice, in mud, in pollen, in the chemistry of shells. These records show us not only what changed, but when. And in them, we sometimes glimpse how fragile societies might have been. Now let us pause gently to see how climate writes itself into memory. In lake sediments, layers of pollen fall each season. By studying the kinds of pollen preserved, we learn what plants grow, and from that, what climates prevailed. In ice cores, bubbles of air reveal ancient carbon dioxide, while isotopes of oxygen tell us whether the world was warmer or colder. In corals, the growth bands record the chemistry of the ocean, sensitive to rainfall and temperature. Each of these is a line in a diary, quiet but durable. Together, they form archives far older and more complete than any human chronicle. Yet we must note the limits. Climate records tell us about conditions, not about how people responded. They show drought, but not whether communities endured or moved. They show cooling, but not whether it meant hardship or adaptation. The link between climate and civilization is complex, and we cannot always draw a direct line. We see patterns, but we must remain careful, knowing that coincidence in time does not always mean causation. Still, the parallels can be striking. Around 4,000 years ago, many regions show evidence of prolonged droughts. At the same time, several early urban centers declined. Did the climate shift cause collapse, or did it simply add pressure to already fragile systems? We cannot say for certain, but the timing invites us to reflect on how tightly life is bound to the environment. Let us now imagine, softly, a thought experiment. Step 1. A society flourishes during a long, warm, wet period when crops grow easily and rivers run steady. Step 2. After centuries, rainfall shifts, temperatures cool, or winds change. Harvests fail, rivers shrink, trade routes falter. Step 3. Within a few generations, the society declines, its cities abandoned. Millennia later, the climate signal is still visible in sediments and ice, but the society is gone, its story erased except
For scattered ruins. This thought reminds us of the fragility of memory compared to the durability of climate's record. Now let us stay for a moment with the language of climate markers. Dust in ice cores shows when winds strengthened, carrying particles from distant deserts. Layers of salt in lakes show when waters dried and concentrated. Tree rings widen in years of rain, narrow in years of drought. Each marker is indirect, yet together they create a symphony of signals, a timeline of change. These signals are among the most trustworthy, for they are written not by humans, but by nature itself. Still, interpretation is needed, and interpretation always carries uncertainty. Before moving further, we can pause to reflect on how these archives shape our understanding of possibility. If civilizations long before us rose and fell, the most enduring evidence of their fate may not be their artifacts, but the climate changes they endured. Their voices may be gone, their tools erased, but the droughts, floods, and temperature swings they faced remain visible in the Earth's deep diaries. We may never know how they responded, but we can know what they faced. And so we drift toward a gentle conclusion. Climate is both a stage and a script, shaping life and leaving its own clear memory, even when human memory fades. It reminds us that the Earth's rhythms are larger than our own, and that civilizations, past or present, exist within those rhythms. What has been lost may remain forever silent, but the climate signals endure, whispering of times of abundance and of hardship. They do not tell us who we were, but they remind us of the forces we have always lived within. In that quiet knowledge, we find humility and a reminder of the fragile place we hold in the long unfolding of time. What if mass migrations, the great movements of people across landscapes, have happened not only in times we know, but also in ages now forgotten? Migration is a natural response to change. When land grows dry, people move toward rivers. When seas rise, they retreat inland. When cold advances, they follow warmth. And sometimes they move simply because horizons invite them, offering the chance of something new. These shifts leave marks, but not in monuments. Instead, they are written in layers of soil, in bones, in the faint record of where plants and animals appear or disappear. We may pause here and picture how this unfolds. When groups move, they leave behind abandoned fields, hearths, and tools. Over time, these become buried, eroded, or scattered. In the new lands, they alter ecosystems, bringing crops, animals, or technologies. Pollen from foreign plants appears in local sediments. Traces of unfamiliar diets show up in bones. Even genetics carries a quiet imprint. DNA in ancient remains reveals mixtures, separations, and new connections. In this way, migration inscribes itself across landscapes and across bodies. Now let us linger on the scale. Some migrations are small, villages shifting a few valleys over. Others are vast, spreading across continents. In the last ice age, humans walked from Asia into the Americas, leaving gradual trails of presence. Yet most movements are less visible, subtle shifts that do not leave monuments. What remains for us are indirect signals: distribution of species, genetic traces, patterns in tools. We cannot see the footsteps themselves. We can only see the echoes. Here we meet the limits of knowledge. Archaeology depends on sites, on preserved contexts. But migrations scatter rather than concentrate.
A mobile community may leave little more than seasonal camps, traces too faint to survive thousands of years. If whole populations moved in distant ages, their stories may be almost invisible now. The absence of evidence does not mean absence of people. It may mean only that they walked lightly and that time erased their paths. Let us try a gentle thought experiment. Step 1. Imagine a civilization in fertile lowlands, thriving for centuries. Step 2.
Long drought comes, rivers shrink, soils crack. People begin to move, slowly at first, then in waves, carrying what they can. Step 3. In their old homeland, nothing remains but dry earth. In their new regions, fragments of their presence mix with those already there. Thousands of years later, all that endures may be pollen from their crops in lake beds or subtle shifts in genetic patterns, while their settlements themselves vanish without trace. This thought reminds us of how movement writes itself indirectly and how much may be lost to silence. Now we can pause on the language of signals. Ancient DNA, drawn from bones or even sediments, reveals patterns of ancestry, showing where groups once mixed. Pollen diagrams reveal when new crops appeared in unexpected regions. The sudden spread of a tool style hints at people carrying ideas across distance. These are threads we can follow, though they never tell the whole story. They are traces of presence, not maps of journeys. They show us that movement happened, but not why, or how, or who. And so we arrive at a quiet reflection. Mass migrations are powerful forces, shaping languages, cultures, and landscapes. They may also have erased earlier societies, blending them into new ones until their distinct voices were gone. If civilizations older than ours once moved or dispersed, their traces might survive only in faint chemical markers, in pollen, in genetics, in patterns too subtle for certainty. What remains is possibility, not proof. The Earth's memory of footsteps is faint, but it is there, written softly into its archives. In that softness, we are reminded of both the vastness of time and the lightness of our passage across it. What if the languages we speak today, with all their roots and branches, are only the most recent blossoms on a tree far older than we imagine? Language is not carved into stone. It is carried in voices, in memory, in the breath of conversation. When those voices fade, the language fades too, leaving no direct trace. Unlike pottery or tools, words do not fossilize. They vanish unless written down. Yet even in their disappearance, they sometimes leave faint echoes, patterns in related tongues, borrowed words, or structures that hint at lost ancestors. Now we may pause gently to consider the scale. Linguists trace modern languages back through families: Indo-European, Afro-Asiatic, Sino-Tibetan, and many more. Each family is a cluster of languages that share deep similarities, like cousins in a vast lineage. By comparing words, sounds, and grammar, scholars can reconstruct fragments of what earlier languages might have sounded like. This method, called comparative reconstruction, gives us glimpses of words spoken thousands of years ago. But there is a boundary. Beyond perhaps 10,000 years, the trail fades. Too many changes accumulate. Too much has been lost. We cannot follow the voices further into the past. Beyond that horizon, silence reigns. Let us linger now on the fragility of oral memory. Before writing, language lived only in the spoken word. Oral traditions could carry stories for centuries, sometimes even millennia. But over longer spans, languages shift and transform. A story told in one tongue may, over time, survive in a different one, its words altered, its shape changed, its origins obscured. What was once a memory becomes a myth, or a fragment, or is lost entirely. This is why the deep past of language is so difficult to grasp. Its traces are indirect,
scattered like faint footprints in sand after a tide. Yet there are ways language leaves signals. Borrowed words, for instance, can act like fossils. When one culture adopts terms from another, whether for tools, crops, or rituals, those words sometimes persist long after the contact itself is forgotten. Ancient DNA carries information about population movements, which can be compared with linguistic distributions. Together, these threads form a delicate web, showing us where languages may have spread, where they may
have mingled, where they may have disappeared. Still, we must remain cautious. The web is partial, full of holes, and always open to reinterpretation. Let us imagine, softly, a thought experiment. Step 1. Picture a civilization many tens of thousands of years ago, speaking languages rich and complex, carrying myths, songs, and knowledge through voice alone. Step 2. As generations pass, the civilization declines, disperses, or vanishes. Their words survive only in the speech of neighbors, changed slowly, blended, carried onward. Step 3. Millennia later, fragments of those words remain embedded in new tongues, like tiny fossils hidden in living speech. We may use them without knowing their origin, unaware that they are remnants of a vanished world. This thought shows how fragile, yet how enduring, language can be, both vanishing quickly and leaving echoes that last far beyond their makers. Now we can pause for a moment on the limits of evidence. Writing, which preserves language directly, appeared only a few thousand years ago. Before that, silence. All that remains are reconstructed forms, probabilities rather than certainties. A word like mother, found in many families of languages, may trace back deep into prehistory. But beyond a certain horizon, the sound dissolves, and we cannot be sure. We face the same humility as in archaeology. Absence of evidence is not evidence of absence. Voices may have risen and fallen many times before, leaving no trace for us to recover. And so we drift to a quiet conclusion. Language is one of the most human of signals, yet also one of the most fragile. It binds people together, carries memory, and encodes knowledge, but it does not endure in the same way as stone or metal. Its record is partial, its past beyond a horizon we cannot cross. What remains are hints, reconstructions, faint echoes that suggest a deeper and older chorus of voices now silent. In that silence, we are reminded not of certainty, but of possibility, that civilizations and cultures may have spoken richly, leaving no trace but whispers folded invisibly into the languages we still use today. What if the arts themselves, painting, carving, music, ritual, once flourished in ages now lost, leaving behind only the faintest of shadows? Art is among the most human of expressions. It does not always serve survival directly, yet it reveals imagination, identity, and meaning. We know it from caves painted tens of thousands of years ago, from figurines carved from stone or bone, from rhythms implied by ancient instruments. But these are rare, fragile, and uneven. Most art, whether sung, painted, or danced, leaves no trace unless preserved by chance. This fragility opens a space of quiet uncertainty, a space where we may ask what has been lost beyond recall. Now let us pause softly to see how art leaves its marks. Pigments pressed into stone may survive if sheltered from rain and light. Carved figures endure if made of durable stone or ivory, but those of wood or fiber vanish quickly. Music leaves nothing physical unless instruments remain, and even then the sound itself is gone. Textiles, performances, rituals all dissolve unless conditions are unusually kind. What we hold today are scattered survivals, hints rather than wholes. They suggest a richness far greater than the fragments imply. Yet we must also acknowledge the limits. A single carved figure does not tell us the beliefs of its makers.
A painted bison on a cave wall reveals skill and perception, but not the full world it belonged to. We interpret, but interpretation is always uncertain. We project meaning, yet meaning may have shifted entirely from what its makers felt. The absence of other pieces makes the context invisible. We know enough to see creativity, but not enough to grasp its depth. Let us linger briefly on the possibility of what lies unseen. If civilizations older than those we recognize once created art, how much of it would survive? Only that which was made of stone or sealed in caves, perhaps. Paintings in the open air would fade. Wooden sculptures would decay. Music,
A calm and interesting voice, read as a scientific topic for sleep, would vanish completely. The chance of finding their art now is small, but the chance that it once existed is not negligible. This is the delicate balance of evidence and possibility. Now let us try a gentle thought experiment. Step 1. Imagine a society thousands of centuries ago, painting with natural pigments on wood, weaving bright patterns into fabric, carving symbols into soft stone. Step 2. Centuries pass. Rains wash the pigments. Insects eat the fabric. Soft stones crumble. Step 3. Millions of years later, only fragments remain, if any. Perhaps a few unusual pigments sealed in soil, or faint scratches on harder rock. To us, their art would be invisible, yet for them it may have been central, shaping identity and memory. This thought shows how presence can be erased almost entirely, while absence does not mean emptiness. Now we can pause on the indirect language art sometimes leaves. Chemical traces of pigments can survive in caves, even when the images are gone. Wear patterns on stone tools may suggest engraving or carving. Resonance in ancient structures hints that sound and music were considered in their building. These are subtle, indirect signals, not art itself, but the shadows of its making. They remind us that creativity leaves marks, even if faint. Still, we must remain humble. For every surviving piece, countless others have been lost, perhaps forever. Before moving further, let us note how art's fragility contrasts with its importance. Art is not an accident. It is a core expression of humanity. Its disappearance from the record does not imply its absence in life. Rather, it reflects the impermanence of its materials and the vastness of time. This lesson reminds us again of the gap between what once was and what remains. And so we come to a quiet conclusion. The arts of lost ages are mostly invisible to us, erased by decay and by time. Yet the few fragments we hold suggest richness beyond measure. Whether in painted caves or in carved figurines, we see imagination, beauty, and meaning. If other civilizations rose and fell before, their art may have vanished entirely, but the possibility of its existence endures. In the silence of absence, we may imagine the chorus of voices, the patterns of color, the rhythm of rituals that once gave shape to their world. What survives is small, but it opens the door to wonder, and in wonder we may rest. What if the tools of science that we use today, precise and intricate, could one day be turned backward to reveal not only natural history, but also faint shadows of forgotten civilizations? Science leaves its own kind of traces, subtle, often invisible without instruments, but durable across time. We know this from our own world. Chemical markers of industry linger in sediments. Isotopes from nuclear reactions remain in soils and ice. Even the quiet accumulation of plastics and metals is now forming a geological layer that will outlast us. If we consider this, then we may ask gently, might earlier civilizations have also left signals too faint for the eye, but still recorded in nature's archives? Now let us pause and see how this language of science works. Isotopes are atoms with the same identity but different weights. Some occur naturally, others appear in abundance only through technology.
Carbon isotopes, for instance, shift when fossil fuels are burned, leaving a signature in the air, the oceans, and even in tree rings. Lead isotopes can reveal patterns of mining and smelting. Radioactive isotopes, such as cesium or plutonium, appear almost only from nuclear activity, and though they decay, they linger long enough to be detected centuries or millennia later. These markers are not dramatic monuments. They are quiet, like faint handwriting in a book of stone. Yet they are more durable than most artifacts. We may linger briefly on the limits. Isotopes fade with time. Some disappear within decades, others within millions of years. Plastic may endure, but pressure and heat can transform it. Heavy metals can disperse, blending into natural background levels. And many
Scientific tools require comparison. Without a baseline, we cannot be sure whether a signal is artificial or natural. Volcanoes, for example, produce chemical changes that can resemble industrial activity. Lightning creates unusual isotopes, too. We must tread carefully, knowing that certainty may be beyond reach. Now, let us imagine softly a thought experiment. Step 1. Picture a civilization 1,000,000 years ago, advanced enough to harness energy and materials in ways we do now. Step 2. Over time, their industries altered the chemistry of air, soil, and water. Step 3. After their fall, nature reclaims the land, erases the structures, recycles the metals. What remains are only subtle anomalies, a thin layer in sediments with shifted isotopes, or unusual concentrations of certain elements. To us, these might look like natural oddities, yet they could, in theory, be the only whispers left of their presence. This thought does not claim that such civilizations existed. It shows instead how faint the traces of technology may become, and how difficult it is to separate human from natural signals. Now we may note some of the signals already present in our own age. The spike of carbon from fossil fuel burning, the spread of plastics into ocean sediments, the traces of nuclear fallout in ice cores. These together have been called a marker of the Anthropocene, a proposed new epoch defined by human impact. If we can create such signals within a few centuries, then others before us might also have done so, even if their signals are now blurred or erased. We cannot prove it. We can only say that the Earth is capable of holding such memory. Before moving on, let us pause gently on humility. Our tools grow sharper, yet the further back we look, the blurrier the record becomes. Even with advanced science, most of Earth's history is quiet, filled with natural rhythms. If there were civilizations older than ours, their signals may have been written too faintly, or erased too fully for us to read. The absence of proof does not tell us they were not there. It tells us only that the archive is incomplete. And so we arrive at a quiet conclusion. The language of science allows us to look for traces beyond the reach of archaeology, traces in chemistry, in isotopes, in the archives of Earth itself. What we find so far speaks of nature and of us. Whether it also holds memories of others, we cannot know. What remains is possibility, not certainty. In that possibility rests both mystery and humility, a reminder that even with the sharpest tools, we see only fragments of a story too vast for us to read in full. What if the oceans, vast and shifting, are hiding most of the story we will never read? More than 2/3 of our planet lies beneath water, and beneath that water are plains, mountains, and valleys as large as anything on land. Yet we know only the surface. The deep sea is largely unmapped, its sediments only lightly sampled, its hidden landscapes still unfamiliar. If civilizations once flourished along ancient coastlines, their traces would now be drowned, sealed under waves, and covered by layers of silt. We may pause here and reflect on how this happens. During the last ice age, much of Earth's water was locked in glaciers.
Sea levels were lower by more than 100 meters, exposing wide coastal plains. Rivers carved paths that are now underwater. Shores stretched far beyond where they are today. When the ice melted, seas rose, swallowing those lands, burying them beneath layers of sand and mud. If people lived there, their hearths, their villages, even their cities would have been erased by the rising tides. Today, their memory may remain only as faint outlines on submerged shelves. Now we can linger on the mechanisms of concealment. The sea is an efficient eraser. Waves break down stone. Salt corrodes metal. Organisms feed on wood. Sediment slowly settles, layering over whatever lies beneath. After only a few thousand years, traces of structures may be hidden, distorted, or gone altogether. Unlike desert ruins, which can remain visible for millennia,
Coastal settlements are fragile, surviving only under rare conditions, sealed by sand or preserved in low-oxygen waters. This is why underwater archaeology is so challenging, and why its discoveries, though few, feel so striking. Yet we must acknowledge the limits. The deep oceans recycle their floors entirely over millions of years, as tectonic plates shift and create new crust. Anything older than that would be drawn into the Earth itself. Even on continental shelves, where sediments preserve more faithfully, much remains inaccessible. Technology has only recently begun to allow careful exploration of these depths, and the ocean's vastness means most of it remains unseen. If civilizations existed before known history, their coastal footprints could easily lie beyond our reach. Let us imagine, softly, a thought experiment. Step 1. A society builds along a fertile coastal plain, fishing, trading, farming. Step 2. Over centuries, the seas rise, slowly at first, then faster, drowning villages and fields. Step 3. Thousands of years later, the plain is a seafloor. Its structures collapsed, covered by sand, its story dissolved into saltwater silence. To us, what remains are only geological features, indistinguishable from natural forms, unless chance or technology reveals more. This thought helps us sense how easily a world can be erased, not by fire or violence, but simply by the patient rising of water. Now we can pause to notice the indirect signals. Marine sediments hold pollen carried from drowned plains, charcoal from fires once lit along coasts, or shifts in microfossils showing sudden flooding of freshwater lakes. These are subtle hints, requiring care to read. They do not show us walls or roads, but they show us change, suggesting where lives may once have been altered by the sea. Even myth may carry faint echoes. Stories of floods, of lost lands beneath the waves, appear in many traditions, told and retold through centuries. We cannot prove they refer to real events, but when read beside geological evidence, they remind us that human memory often lingers in story, even as land disappears. Before we move further, let us reflect on humility. The ocean is larger than our knowing, and its ability to erase is greater than our ability to search. Yet the possibility remains that what it hides is not only natural, but also human. The silence of the seafloor is not evidence of absence. It is only a reminder of our limits, of how little we have seen. And so we drift to a gentle conclusion. The oceans are both archive and erasure, capable of preserving traces under mud, yet also capable of dissolving them completely. They hold secrets of coastlines lost to time, worlds that may once have been alive with voices, and now lie in quiet darkness. We cannot say what is there. We can only acknowledge that much of our planet's story lies beneath the waves, unread and perhaps unreadable, yet still part of the vast memory of Earth. What if deserts, which now seem empty and silent, once carried the weight of life and voices that time has since erased? When we look at wide expanses of sand, we tend to see stillness. Yet deserts are not timeless.
They move, they grow, they shrink, they remember. A desert is like a shifting sea made of grains instead of water, and beneath its surface, earlier landscapes can remain buried, sealed in dryness. We may pause here to reflect on how this happens. Deserts form when climates change, when rainfall withdraws and winds take over. Forests and grasslands turn to scrub, scrub to sand, and eventually dunes roll across the land. But the land beneath still holds its older story. Rivers that once flowed, soils that once grew crops, even lakes that once supported settlements. Dryness in its own way can be a preserver. In some places, textiles, wood, and even seeds survive for thousands of years, locked away from decay by the absence of water. Deserts conceal as much as they erase. Let us linger now on the signs they leave. Satellite images sometimes reveal faint outlines of buried rivers, old roads,
Forgotten walls, hidden beneath sand. Archaeological digs in places like the Sahara have uncovered pottery, tools, and bones in areas now barren but once green and alive. Geological cores taken from beneath dunes show layers of pollen, telling us what plants once grew there. These are indirect voices, hints that deserts were not always empty, that they once held human presence, now veiled by shifting landscapes. Yet we must recognize the limits. Sand moves constantly, covering and uncovering in cycles. What is exposed today may be buried tomorrow, and what lies deep beneath may remain unreachable. Winds destroy as much as they preserve, grinding stone to dust, scattering fragile remains. Our knowledge is therefore fragmentary, drawn from rare finds and fleeting glimpses. For each discovery, countless others may remain hidden or lost forever to the drifting tides of sand. Let us try a thought experiment. Step 1. Imagine a thriving community at the edge of a fertile river, building homes, cultivating fields, and shaping tools. Step 2. Centuries pass, the climate shifts, the river dries, and sands advance. The settlement is abandoned, and dunes begin to cover it. Step 3. Millennia later, the land is an unbroken desert, its past erased to the eye. Only under the surface, under layers of dryness, do traces remain. A shard of pottery, a wall of mud brick, a seed fossilized in salt. To us, the desert seems eternal. To time, it is only a passing phase. Now we can pause on the language of archives hidden in arid lands. Desert soils can trap salts, which tell us of ancient water. Fossilized pollen marks the passage from green landscapes to barren ones. Even the chemistry of sediments, preserved under dunes, can reveal whether a region once hosted lakes or crops. These markers are not dramatic, yet they whisper of change, of life once flourishing where silence now reigns. They are patient signals, awaiting careful reading. Before moving further, we may note how deserts remind us of impermanence. What appears barren may once have been rich. What is hidden may one day return to light. And the memory of earlier civilizations, if they existed there, might rest beneath sands still unmapped, unseen by human eyes. We cannot know for certain, and we may never uncover the full story. Yet possibility endures, carried quietly by the desert's silence. And so we drift to a gentle conclusion. Deserts are not voids, but shifting archives. They preserve fragments even as they erase landscapes. They show us that time transforms, that what we see as empty may have been full, and that what we consider permanent is only a moment in Earth's long unfolding. If others walked these lands before us, their traces may yet sleep beneath the dunes, hidden but not wholly gone, awaiting either discovery or eternal rest in the quiet of the sand. What if the mountains, steady and immovable in our eyes, have quietly hidden entire chapters of forgotten lives? Mountains rise slowly through tectonic shifts,
pressing stone against stone until the land folds and lifts. Valleys deepen, glaciers carve, rivers cut their paths. To us, they appear eternal, yet they are restless archives. Within their cliffs lie layers of rock, each one a page of time, pressed with fossils, sediments, and sometimes even traces of human presence. We may pause here and notice how mountains work as both preservers and erasers. They preserve when caves hold artifacts safe from wind and rain, when dry air shelters wood and bone, when rock collapses gently and seals what lies beneath. They erase when glaciers grind stone to powder, when landslides bury settlements, when rivers scatter tools and bones far from where they were left. Mountains, in this sense, are not only landscapes, but also editors, deciding what fragments of history endure and what is lost. Now let us linger on the signals they offer. Caves have given us some of the earliest art, paintings, handprints, carvings. High plateaus have revealed evidence of ancient dwellings, terraces, and paths. Even pollen,
Trapped in mountain lakes, tells us what plants grew long ago, hinting at whether slopes were forested or cleared for fields. Isotopes in ice, trapped within glaciers, reveal temperature shifts, showing how people may have moved with changing climates. These are indirect voices, quiet but durable, the mountain's own record of time. Yet we must acknowledge the limits. For every cave that shelters drawings, countless others collapse. For every terrace that endures, many more are swept away by erosion. Mountains are dynamic, shifting slowly yet powerfully. Their very movement means that what was once surface can be thrust deep below, folded into rock where it will never be seen again. Our picture is therefore partial, drawn only from those fragments that chance has spared. Now let us attempt a thought experiment. Step 1. Imagine a community living on a fertile mountain slope, cultivating fields, carving paths, and painting walls of caves with stories. Step 2. Centuries pass, the climate cools, glaciers advance, and landslides bury villages under stone. Step 3. Thousands of years later, the glacier retreats, the slope erodes, and fragments emerge. Perhaps a piece of painted rock, a tool embedded in gravel, a layer of charcoal in the soil. To us, these seem like isolated puzzles. To them, they were a world entire, now reduced to scattered signals. This helps us feel how fragile memory is against the strength of the land. Now we can pause to see how science reads the mountain's diary. Rock layers reveal not only fossils, but traces of past environments. Dust from deserts carried on winds, volcanic ash marking sudden eruptions, even heavy metals showing where smelting once occurred. Ice cores drilled from glaciers contain trapped air, preserving atmospheres from ages past. Together, these records let us trace shifts in climate, vegetation, and sometimes human impact. But interpretation is never simple. Natural processes mimic human ones. A fire recorded as charcoal may have been lightning, or it may have been deliberate burning. We tread carefully, knowing that certainty is rare. Before moving further, let us reflect gently on scale. Mountains are vast compared to us, and their time scales are longer than our memory. What we see as eternal peaks are only temporary shapes in Earth's long story. Civilizations that lived upon them may be erased, preserved only in faint signs beneath stone or ice. The absence of visible ruins does not mean absence of life. It may mean only that the mountain, in its silence, has folded them into its deep archive. And so we drift to a quiet conclusion. Mountains are not only monuments of nature, but also keepers of hidden memory. They preserve fragments and erase worlds, offering us glimpses but never the whole. If civilizations once rose and fell upon their slopes, their traces may lie in caves, in ice, in scattered sediments, awaiting discovery. Or they may lie deeper still, beyond reach, folded forever into the stone. What remains for us is not certainty, but humility. and the calm awareness that even the highest peaks hold more stories than we can read. What if forests, with their layered canopies and deep roots, are not only living systems, but also veils that conceal what came before? Forests grow quickly in geological terms. Within a few decades, trees can cover abandoned fields, roads, or villages, weaving roots into walls and pulling stone apart. Within centuries, soil forms over ruins, and only faint mounds remain beneath moss and leaf litter. To us, the forest feels ancient, yet in truth it is both a preserver and an eraser, hiding traces beneath its quiet green surface. We may pause here to reflect on how this happens. Plants reclaim open ground with speed. First grasses, then shrubs, then trees, layer upon layer. As roots penetrate, they break apart foundations. As leaves fall, they form humus that buries what lies below. Rain and growth together build new soil, while vines wrap around structures and slowly pull them down. What once was human becomes part of the living
cycle of the forest. Yet under this cover, fragments remain. Now let us linger gently on the kinds of signals hidden there. Archaeologists sometimes find outlines of old roads under dense canopy through satellite imagery, using subtle differences in vegetation to trace forgotten paths. Ground-penetrating radar can reveal buried walls and foundations without disturbing the forest floor. Pollen trapped in swampy forest soils tells us when farming once replaced wild growth, and when wild growth returned after abandonment. Even charcoal layers in earth show us when fire cleared the land, whether naturally or through deliberate cultivation. These are indirect voices, whispers of earlier presence beneath the roots. But we must acknowledge limits. Forests thrive on moisture, and moisture decays what humans leave. Wood rots, metals corrode, textiles dissolve. Only stone, ceramics, and rare sealed conditions endure. Even they can be fractured by roots or scattered by animals. Over thousands of years, most traces may fade until only small anomalies remain. To read such faint signals requires care, and even then, certainty often escapes us. Now let us try a soft thought experiment. Step 1. Imagine a settlement at the edge of a fertile plain cleared of trees, filled with fields and paths. Step 2. People move on or decline, and slowly the forest advances, reclaiming soil, wrapping its roots around walls, building layer upon layer of green. Step 3. Millennia later, the forest appears untouched, a wilderness. Yet beneath its floor lie fragments, stone tools, pottery shards, faint lines of earth darker or lighter than the soil around them. To us, it is only forest. To time, it is both forest and archive, one life layered upon another. Now we may pause to see how science listens to these hidden signals. Satellite images in different light spectrums can detect changes in vegetation that mark buried structures. Soil chemistry reveals patches once enriched by human activity, phosphates from farming, ash from hearths. Even tree rings can hold clues, reflecting sudden shifts in landscape use, or moments when fields were cleared before forest returned. Together, these subtle signs form a quiet map of what once lay hidden. Yet none of this is simple. Forests themselves shift, growing and dying, covering and uncovering across cycles of centuries. What appears natural may once have been cultivated, and what appears cultivated may once have been wild. The line between human and nature blurs, and the story becomes harder to trace. Before moving further, let us reflect on the humility this invites. Much of Earth's surface is or was forest, and much of it has been reshaped many times over. The voices of earlier ages may be buried under layers of living growth. Their absence from view does not mean they never existed. It may only mean that the forest has folded them into itself, where only faint echoes remain. And so we arrive at a quiet conclusion. Forests are not only living ecosystems, but also soft veils drawn over the memory of the land. They erase and preserve at once, turning stone into soil and hiding fragments beneath roots and leaves. If civilizations once rose and fell in places now covered by trees, their stories may sleep in silence beneath the canopy. The forest does not deny them, it simply keeps them hidden, whispering their memory in pollen, in soil, in patterns of growth. What we see is green, alive, and present, yet beneath it lies a deeper, older layer of time, folded gently into the earth. What if the very air around us, light and unseen, carries memories of times long past? Atmosphere is not only what we breathe, it is also an archive. Each layer holds chemical signatures, faint but enduring, like whispers preserved in glass. In ice cores drilled from polar regions, tiny bubbles of air remain trapped, frozen snapshots of what the sky once was. By studying them, we can trace climates, volcanic eruptions, even the industrial breath of societies. This shows us that air, though invisible, records history with quiet precision. Now we may pause.
And notice how this works. Every time something burns, wood, coal, grass, it releases gases into the sky. Volcanoes do the same, scattering sulfur and ash. Plants breathe in carbon dioxide and release oxygen, slowly shifting balances. When snow falls and compacts into ice, tiny pockets of this air are sealed within. Over millennia, they stack into layers, like pages in a book written in frost. By reading these bubbles, we learn what the world once exhaled, and sometimes what people once did. Let us linger on the kinds of signals found here. A sudden spike in carbon dioxide might reflect the burning of vast forests. Traces of methane may reveal the spread of wetlands or agriculture. Ash particles can mark eruptions, but also distant fires. Even lead has been found in ancient ice layers, pointing to smelting thousands of years ago. More recently, radioactive isotopes left by nuclear tests linger as markers of the mid-20th century. Each of these signals is subtle, yet together they weave a quiet story of both nature and humanity. Still, we must acknowledge the limits. Air is restless. Winds mix gases across continents, blending local signals into global averages. Some chemical traces decay quickly, leaving no lasting record. Ice cores preserve well in polar regions, but elsewhere the atmosphere leaves fewer lasting marks. We must also be careful not to mistake natural events for human ones. A great volcanic eruption, for example, can leave a signal much like widespread burning by people. The line between the two is often blurred. Now let us soften into a thought experiment. Step 1. Imagine a civilization tens of thousands of years ago, burning fuels for warmth, for craft, perhaps even for industry. Step 2. Their smoke rises into the sky, changing the mix of gases, scattering particles far on the wind. Step 3. Centuries pass, and their fires end. The air clears, but in frozen layers at the poles, some of their breath remains, sealed in silence. To us, such a signal might look like natural change, or perhaps it would be too faint to notice. Yet in theory, the sky could have carried a memory of them, written in molecules rather than stone. Now let us reflect gently on the language of the air. Even today, we see our own presence in it. Rising greenhouse gases, ozone changes, traces of pollution carried to the farthest corners of the earth. These will remain as subtle layers for future ages to read. If we can leave such marks so quickly, it is not impossible that others may have done so before, even if their signals have faded or become indistinguishable from natural rhythms. But we cannot say with certainty.
What we have is not proof of hidden civilizations, only the awareness that the air is capable of memory. Before we drift onward, let us hold this thought with humility. The sky above us feels endless, but it is fragile, thin, and able to change. It forgets much, but not all. Its bubbles and ice are small, yet they hold centuries, even millennia of breath. They show us how carefully we must listen, how patient we must be to read what remains. And so we come to a quiet close. The atmosphere is both present and archival, carrying the story of Earth and perhaps of us. What it remembers is faint, fragile, but real. If other hands once shaped fire and breath long before our time, the air may have carried a trace. Whether we can ever distinguish it, we do not know. What remains for us is to listen to the whispers in the ice, to the chemical shadows in the wind, and to rest in the awareness that even the air we breathe may be part of a story older than we imagine. Before us, we might ask whether their signals too could have slipped into the fabric of space, now diluted but not erased. Let us pause here and think of how this works. Every source of light leaves a trace. When people gather fire, the glow spreads upward, though quickly lost in the brightness of the sun. When vast fields are burned, smoke alters the color of the air. Today, satellites orbiting Earth can see the spread of cities at night, or the haze of industry by day. These are examples of what might be called planetary signatures, marks of human life visible not only to us, but in principle to any distant observer. They remind us that civilizations, in living, alter the planet in ways that extend outward. Now we may linger on the signals themselves. The night sky as seen from orbit shows webs of light that match our cities. Radio signals, once powerful, spill into space, spreading spheres of faint noise across the galaxy. Shifts in the chemical makeup of our atmosphere, more carbon dioxide, more methane, could, in theory, be read by instruments from another world. These are what scientists sometimes call technosignatures, indirect signs of technology, though they need not be advanced to exist. Even simple burning, carried out on a large scale, could leave a global mark. Yet we must acknowledge the limits. Space is vast, and signals weaken as they spread. Light is scattered, radio noise fades, and only the strongest or most unusual patterns endure. If earlier civilizations rose and fell long before us, their signals might now be lost in cosmic background, drowned by time and distance. On Earth, too, the evidence is delicate. Fires may leave charcoal, but not proof of intention. Atmospheric changes may reflect volcanoes as easily as industry. To read certainty in these signs is nearly impossible. Now let us soften into a thought experiment. Step 1. Imagine a civilization long ago that mastered fire on a scale large enough to change the sky. Step 2. Their activities fill the air with smoke. Their fires glow across the land, and from orbit, if there had been satellites, faint grids of light would have appeared. Step 3. Thousands of years pass. Their fires go out, their structures vanish, but in ice cores or sediments, traces of unusual soot remain, a ghost of what once illuminated the night. To us, those marks are ambiguous, but to them, they were the glow of life. Now let us pause on how the cosmos itself might act as archive. Every photon of light carries information. Some of it is scattered, some absorbed, some traveling still through space. Astronomers use this principle to study distant planets, reading the fingerprints of gases in their atmospheres. If others can do this to us, then in principle, we can imagine that past civilizations, if they altered their skies, might have left atmospheric signals too. Perhaps faint, perhaps fleeting, but not nothing. Still, we must remain careful. Absence of such signals does not prove they never existed, and presence, if ever found, might still resist clear explanation. The cosmos, like Earth, speaks in a language of traces, never full sentences. Before we move on, let us take a moment to reflect on humility. We often think of stars as eternal, but even they shift, flare, and fade. The same is true of civilizations. If light and air can carry traces of us, they might also have carried traces of others. We may never read them, but knowing they could exist stretches our sense of time and place. And so we drift to acquired close. The stars remind us that everything leaves a mark, even if faint. Fires glow, air shifts, signals spill outward, and traces are carried across space. If humanity has risen and fallen before, perhaps some of their memory is written not only in stone or soil, but also in the sky. We cannot claim to know. We can only recognize that the universe itself may be a vast, gentle mirror, reflecting back fragments of stories older than ours, waiting in silence for someone to notice.
What if the story of humanity is not a single line, but a series of arcs, rising and falling, repeating in rhythms we can only partly sense? We stand in the present, surrounded by our own achievements, yet the earth beneath us is layered with countless pasts. Some we know, some we guess at, and some may be gone beyond recall. It is humbling to consider that what feels permanent to us might, in the scale of time, be as brief as a flicker. Civilizations may bloom like forests in spring, full of life and promise, only to recede like autumn leaves, leaving traces pressed into soil, ice, and stone. Now we may pause to gather what we have noticed along the way. Rivers carry fragments of stories, burying and revealing. Oceans preserve and erase, holding memory in sediments but dissolving the fragile. Mountains rise as archives, yet shift and fold, hiding as much as they display. Forests grow over ruins, turning cities into soil. The atmosphere itself holds whispers of breath and fire, while even the stars, in their quiet light, reflect what has been sent outward. Each domain leaves its own kind of signal. None is complete, none is unbroken. The language of traces is one of fragments, scattered and subtle. And yet, by listening across many layers, we can begin to imagine patterns, even if we cannot see them fully. Now let us gently acknowledge what we do not know. We cannot prove that civilizations before us rose and fell, nor can we prove they did not. The absence of evidence may be only the silence of time, not the certainty of nothing. Erosion, burial, cycles of climate, and the fragility of human works mean that much is lost. What survives is chance, not completeness. This is why we must move with care, reading cautiously, never claiming more than the traces allow. Yet uncertainty is not emptiness. It is space for reflection, for wonder, for humility. Let us try one last thought experiment together. Step 1. Imagine that we, too, are only one layer in a longer rhythm, our cities and machines destined to fade, leaving faint signals in soil and sky. Step 2. Imagine that far in the future, others walk the earth, finding fragments of our time, bits of plastic in sediments, isotopes in stone, perhaps ruins half hidden beneath forests or ice. Step 3. Imagine their quiet curiosity, wondering if they are the first or only the latest in a series. To them, we may be as shadowy as those we now imagine. This thought does not diminish us. It places us gently within the larger flow. Now let us rest on the sense of scale. Time stretches far beyond the span of any one culture, even any one species. Stars rise and fade, oceans shift, mountains crumble and grow again. Against this backdrop, our stories are brief but not meaningless. Each trace we leave becomes part of Earth's memory, woven into layers that may one day be read, or perhaps only felt in silence.
The lesson here is not fear, but perspective. We are part of something vast, and what we build, though fragile, joins the great archive of the planet. And so we drift to a soft conclusion. Whether humanity has risen and fallen many times before, or whether we are the first ark in this rhythm, remains unknown. What we can hold with calm is the awareness that traces endure, even when stories are forgotten. The earth, the air, the waters, the stars, all keep memory in their own way. And perhaps that is enough. If we listen to their quiet language, we find not certainty, but connection, not proof, but presence. The story of humanity is still being written, and in time, others may read what we have left. Until then, we may carry with us the gentle thought that we are both temporary and timeless, flickering, yet part of a long, unbroken glow. If this rhythm feels close, we know where to return.